Now, on this particular part, it says it's an assembly. So are you typically going to be working off just these 2D information, or would you be using this model that you have in here for working with it?
The model is just primarily for assembling the builders. We just kind of do it as a general guide.
Okay. So in terms of CAM programming or machining, you're looking to just use this information right in here for programming it, right? These sheets that you have right here?
Yes.
Okay. All right. Perfect. Okay. So what I could do here is we could, just have this information visible, and we can, organize it in such a way that all the other information can be put on a different layer or hidden in Rhino. So you can basically just select the objects that you'd like to retain for programming. I'm just using all of the Rhino tools as you see right here. And then I can do an invert selection in Rhino. You can do a edit, select objects, use invert, or you can use the keyboard shortcuts, or if you want to type it in, you can do that. So I'm going to basically flip everything else, and then I'll just put it on a different layer in there. So I'm going to say change object layer, and then hide the rest. Okay? So this is the information that we need for programming our toolpaths or machining operations in here. Now I see you have two different sheets. So are you going to be programming both the sheets side by side, or would this be programmed as two separate operations?
Two separate operations.
Okay.
Yeah.
So the typical workflow here is once you have your file drawn or imported or have it ready in Rhino, you want to go directly into the RhinoCam browser. So you want to click on RhinoCam and Mill. Now, if the browser is not visible or if it's not loaded, you just select RhinoCam and Mill. It basically toggles the visibility of the browser back on. And the browser has two browser windows. One is called the machining browser, which is appearing over on the top half. And then on the bottom half, or maybe on the side, you'll see a machining objects browser. The machining objects browser allows you to define tools. You can load your library of tools in here. I have a standard library created. I just load them automatically when I open up a part. You can see these tools are loaded. We have different tool types. We support ball and mills, flat end mills, corner radius, tools for engraving, chamfer, taper, thread mill, face mill cutters. You can have dovetail tools, fillet milling tools, lollipop cutters. You can also do form tools where you can actually create a profile of the tool, a cross-section of the tool, with the tip of the tool being at the origin, and you just highlight the tool and do a load selected profile. It'll revolve with the former tool. And then you have all of your drilling tools in here: drill, center drill, reamer, tap bore, and reverse bore. Now each of these tools, you can have multiple tools defined on each of these tool types. You can assign your properties in here, your tool number. If you have an automatic tool changer, you can make sure it matches the tool that's on the machine. You can set up coolant types if you need to. If you're cutting metal, you select your feeds and speeds. We also have a built-in feeds and speeds calculator in here based on the material you're going to be cutting. RhinoCam can help you with recommendation of feeds and speeds. If you pick graphite and high-speed steel, it tells you that based on the surface speed of the graphite material, these are the recommended parameters for your feeds and speeds. So you can use this calculator. You can also add additional material types to the list in here to customize the list of materials as well. Any questions so far?
Not so far.
Do we have some of those tools?
We use, yeah, we use some of them. We use, I think the way you're doing it, you can actually customize your own, you put your own tool list in there.
You got to put your diameter in here, flute length, shoulder length, you define it. So these are the standard tool types like ball mills, end mills, flat mills, or square end mills, corner radius. So each of these, you define tools under each of these types.
And then when you get that in there, you can freeze that so that we can apply it to anything we do from then on.
Absolutely. Yeah. You can load the library on all the parts you're working on, so you don't have to recreate the tools over and over again. So it avoids repetition of, and you can also save your workflow of machining operations also to a knowledge base, and I'm going to show how that works. Now, what we could actually do here is we can treat these as two separate parts, and one of these parts we can program it on a separate file as well. So I can take this in here, and I could do export selected in here. I'll put it into the same folder where we have the files, the one that we have for you saved in here. So I'm going to put it in the same folder, and I'll put it in there as Rhino 3DM files. And I'm going to call this, part 2, right? I'm going to call it part 2. So I just exported just these drawings in here. So let's, for example, also ignore this piece of information. So all we have is this particular drawing to work on to start with, right? So once you have your tools loaded in here, the first step is we go into the Program tab. We define the machining process. Now, for 2 and 3 axis, it's automatically set to 3 axis. So if you're looking at just the standard configuration, then you don't even have to make a selection in here. It's set to 3 axis. We have additional options like 4 and 5 axis in our expert and then professional configurations. Now, if the machine has an automatic tool changer, you don't have to use a tool change point. If you're working with a manual tool changer and you like to move the cutter to a specific XYZ coordinate position to perform a tool change, you can input this information, the coordinate value, and this can be output in the posted code. In the next step, you want to make a selection for your post processor. The post processor is the flavor or the output format of the G code that your machine is expecting. So the posts in here are listed either by the name of your machine tool or by the controller name. Do you happen to know what post processor you'll be needing?
We've got a custom one day Bobcat made up and they purchased the software.
Okay, and what is the machine that you have so I can look it up here to see if we have one that closely matches to that?
VR508.
I'm sorry, can you repeat that again, sir?
It's a Como VR508.
Okay, so it's a Como. So we have several different Como posts in here. If you look at the post in here, the closest one I have is a VR1605. So I can pick this post and we can customize it for you. So all I need is to have you send us a sample G code, and I can go ahead and modify the post processor and create a new one in the list for you. Okay?
Yeah.
So we can also specify the extension. Does your Como machine require the post to be .nc, or if it's a different extension, we can specify the file extension right in here as well.
We are running NC, and it's
okay,
real
great.
enough front end.
Okay. So once you got this machine and posted up, you can see that all the information in here is updated under machining job. The next step is you want to establish the orientation. Now, on some machines, you have more travel on the y-axis as compared to x. If it's a router, then you probably have more travel on the y. But in some machine tools, the routers are set up so that the x has more travel. So in this particular step, you want to determine if you need to rotate the part or not. So the way we currently have it set up is your stock needs to be basically 96 on X and 48 on Y. So does your part need to be rotated around so to fit the work envelope of your machine, or is this the correct orientation as you look at it looking down at it from the top?
Correct as it shows on the screen.
Okay, so that's great. So what would be the thickness of your material? Is it going to be 3/4, or what do you typically use for material thickness? I'm sorry?
Yes, 3/4.
3/4? Okay, so I'm going to put in 0.75. And the next step is we want to establish where you would like to put your XYZ origin. So you can notice that the stock has been defined, and currently the drawing is sitting at the base of the stock. So you can do align stock, and you can have the drawing be flush to the top of the stock, so Z alignment to the top. And currently your 000 is over here on the top left corner of the drawing or the sheet. And you can specify where you want to put your XYZ origin, which could be your work offset, your G54 or G55. And currently it is where the origin is in the CAD, since you already have the part drawn at the origin. Would you like to specify a different origin for this part?
Not at this time. The way we've been running it with our other milling package is we lay the parts out like this with pre-arranged buffers, and then do the boring or drills, and then internal cuts, and then perimeters.
Okay, all right. So we could do the same thing in here. So the next step I'm going to do is program the toolpaths in here. So since you already have these features in here, I'm going to go ahead and quickly check the diameter in here. So this one is 0.4376. So do you have a drill bit that matches the size of the holes, or do you want to use a standard size drill bit for it?
We match the drill bits to the boring size.
Okay, so I'm going to go into hole machining and select drilling. As you can see, the hole machining is found right here. You can pick drilling.
Okay.
And then you select the drill points. You can just go ahead and drag the objects that you want to select for drilling. So you're basically taking advantage of all of your Rhino selection tools in here. So if you had them on layers, you can just do a select by layer, or you can do select by geometry type. So you can just go ahead and grab them right there. So we can help you organize these objects into layers so we can automate a lot of the selection process as well. And I'll show you how to do that. Now we have all of these holes selected. You can see there's a total of 12 holes that are being added right there. The next step is to make a selection for the tool. Now you could be using even end mills for drilling operation, or we can have a drill tool that's defined which matches the size of the cutter, right? So it was 0.4376. I can put in a .4376 drill bit right here, and I can have a drill tool defined. And this can go into a library, so I can add this new tool to my library right there. And then I go to my feeds and speeds. My clearance is set to automatic. In the cutting, all I got to do is put in the total depth is 3/4, and you want to make sure that the tool tip is compensated. So if it's going to be a through hole, you want to go all the way through, right? So you can say add tool tip, and the system will automatically compute how much the tool needs to go past the stock material in order to clear it fully. So you're going down into your spoil board a little bit so that you're getting a through hole because the tool has a 118 or a 120 taper, which is typically common for a drill bit. And you can also sort them going in a certain sequence in here, and then you pick generate. So you have your drilling toolpath programmed. So you go to simulate, you run a verification. Any questions?
Looks good.
The next step is we want to program the inside features, right? So do you want to do an ID cut on all of these, or are these going to be OD cuts, outside diameter?
Those parts will be OD. The only internals will be the small rectangular pieces. Yeah, those.
Okay. And what size cutter would you like to use? Make sure to fit the radius in here. So if you analyze a diameter in here, I can check that, and that's going to be 0.45. So if you have a tool that's less than a 0.45, you should be okay, right? Like a 3/8 cutter or a 1/4 inch. Do you have a preference on what size cutter you would like to use?
We're running either 5/16 or 7/16. I'm not sure.
Okay, so we'll go ahead and add a tool in here. And do you want to basically just do a profile cut, or do you want to hog all the material out on the inside?
No, just
Just follow the
perimeter
contour.
cut. Inside perimeter.
All right, so we do what's called profile for that. So we do profile,
Right.
and then you can just go ahead and select the geometries in here. I can just grab a window, select it, and I'm going to grab a tool in here, and you say it's going to be 5/16. So I'm going to create a new tool. I'll put in the tool name as 5/16, and I'm going to type in 5/16, so I don't have to worry about figuring out what the value is. We do automatically take care of computing the fraction for you right there. I can save this up as a new tool. It automatically looks for a tool number that's available and then creates a new tool. You can go back and override the tool number as well. Again, everything is set here. Feeds and speeds, clearance is set to automatic. In the cutting, you choose what direction you want to cut, climb or conventional, and you can choose outside or inside. In this particular step, you want to go on the inside. In the cut levels, you specify the depth in here. If it's going to go all the way through, you want to go 3/4, or if you want to add slightly like a 50 thousandths additional to it, you can add that as well. You can specify in how many passes you want to cut it. In one pass, or you can do like multiple passes. I could say I want to do 3 pass, 1/4 inch each. You can do that. You can also specify entry and exit. You can do lead in and lead out, or if you just want to cut it a plunge, you can set it to none. And you can specify parameters to fit arcs to tool paths automatically, and you can do a sorting, generate it. So we now have the tool paths for those 4 inside features. You can run a verification. It shows the cutting process in 3 steps. Okay?
Now, to back up slightly, in the upper right corner there's 2 small pieces that also have drills that we bypass. Can you add those at this point?
Yeah, I already had the drill operation included as the first operation. I had it with the same hole selected.
Oh, yeah, but if you look at the upper right corner of that, or upper left corner of that sheet.
Yep, I missed them out. So I can go back and add it in here. Just double click on it, select drill points, and I just go back and add them to the operation generated. So now they're all added into one operation. You see now all the holes are drilled. I can go back and add it. So you can always edit the operation to go back and add or drop features to it. All right? So the next thing I want to do here is do the profile for the exterior shapes in here, right? So I'm going to reuse the same operation, do a copy and a paste. Now I'm going to go back and modify this operation in here, drop all of the inside features, and use select curve edge regions. And I'm going to use the crossing window selection in here in Rhino. So I'm taking advantage of all of the Rhino selection tools to select these geometries in as fewer clicks as possible, right? So I'm basically dragging a window to select all of these objects in here. So you can take advantage of all your selection tools in Rhino. You select all of them in here, And all I'm doing is switching from inside to outside and generating the toolpaths. Now, if I would like to leave any bridges and tabs, you can do bridges and tabs right there. You can leave bridges and tabs, so basically the pieces can be held with the stock, or if it's going to be vacuum held, then you probably won't need bridges and tabs. You can do like an onion skin and then do a written onion skin to go back and clean it up if you need to. And now when I do a generate, the toolpath is now generated for the OD, as you see right there. And now I can go run a verification for it. And it's automatically set to do a sorting based on minimum distance between two or more parts. So it figures out the closest distance between two or more adjacent parts based on the start points and figures them out for you.
Okay, I got a question.
Sure.
Now, whenever you get done with your program and you know you're drawing, you have your actual your program in, and it's already, I guess you already posted it. Is there a way to actually save the actual drawing that it's doing now with all your toolpath lines and all that stuff to go back and look at it later in case you have a problem?
Absolutely. When you save this file in Rhino, all of this information gets saved to the same Rhino file. So if I hit save, everything is just saved in here.
Okay.
So now when I go back in here and reopen this file, it contains all of your machining operation in it. So you don't have to go back and recreate any of the toolpaths. So your toolpaths are saved. The CAM information gets saved to the same Rhino file. So if you happen to make a change or move, you don't have to start all over again.
Yeah, okay. I like that.
That's the beauty of working within Rhino and using Rhino CAM. And now when you do a post,
we're not able to do that. We're not able to save any like the toolpaths or anything like that. You know, it's just we're able to save the program and that's it.
Right. Here is everything is associative as you can see it.
Yeah.
There's your posted code right there. It does call out your tool numbers. You can now put the tool information at the start right there, the 3 tools that are being used. And there's your G code, which is ready to be sent out to the machine.
Okay, well, I have another question. The lady that I talked to that set this up, and she was giving some information last week about it. It said you could actually go in and you could alter your drawing, your sizes on your drawing, and it would automatically update your G code in your program without having to go back and do all that. Is that how does that work, or is that, did I misunderstand it?
So if you make a change to the drawing, you want to update it. So for example, in here, let me go back in here and I'm going to take a look at this part right here, right?
Yeah.
So I could do I'm going to modify this here. I'm going to scale this part, and I'm going to scale it. I'll pick the snap tools in here in Rhino. So I'm going to find the midpoint of this. I'm going to use the smart tracker in here to get the midpoint of these two. So basically, I got the intersection of the two. And then scale reference point, I'm going to put in, I want to make it 1.5 times. So you see that when I made this change, modify this drawing, you notice that the operation that this particular drawing was selected under is marked as dirty or flagged. So now all I got to do is right-click and regenerate, and now my toolpath for that is updated. Now if you add changes to it, if you make an edit to the drawing, you just have to go back and reselect it. So if you modify, if you split, you added something in here. But in this particular case, I scaled it. So all I had to do is go back and just regenerate the toolpaths, and the toolpaths are now updated right there.
And I'm not trying to rattle yours off. Another question. She was telling me too that like the problem we're having now is like our post processors. You know, we don't have support on the software we're using now. And she said that y'all actually had a library where you could go in and change your post processors anytime, or?
Absolutely. The post processors, all the post processors that you're looking at here are included with the product. And we will also help you set up a new post processor. If it isn't found on the list, we can create one, and you do get full support on the product from us. And we will help you edit the post.
What about support? How long after we buy the software we support? I mean, is it as long as we own it, or
you get phone support, you get email support. We also do remote logging into your computer to help you troubleshoot issues. So we do offer what's called a maintenance subscription that will allow you to stay current on the product. So in addition to getting priority support, you'll have access to what is called monthly webinars. You also have access to training recordings, and on top of it, you get the version upgrade. So when we release version 2018, you will get that because you are current on your maintenance subscription of the product.
Oh, you automatically upgrade it as long as you're.
Yes, along with the product, you'll add what's called a maintenance subscription, and that'll keep you current. So year after year, you just basically continue your maintenance subscription.
Everything I do draws in AutoCAD.
Could you run a nesting simulation with these pieces?
Sure. We have a module for nesting in here. I'm going to show that to you in just a moment. Now, so let me go back and do an undo here so you can see that the size is shrink back. If I go back and regenerate, your toolpath is updated as you see it right there. Now let's go ahead and save this work in here. I'm going to do a save. And then also I'm going to take this workflow of operations in here and save them to a knowledge base. So if I have similar parts that require a similar workflow, I just load those operations and then just select the geometry. So I don't even have to go back and select the tool or put in the depth because all of the information is saved in like a template in here. So you don't even have to go back and, change your parameters unless you need to. Now let's see how we can nest these parts into a sheet, right? So you want to take these parts in here. So what I'm going to do is select these parts in here, and basically I'll make some copies and I'll show you how I can nest them. Is that what you want to see, sir?
Yes.
Okay, so would you let me know what parts I should be nesting? Can you give me like just a
drill? Something with a drill and that we're not there. Well, it's kind of big. Something with a drill and an outer cut.
Okay, so I'm going to select this part right in here.
Yeah.
Yeah, I'll go ahead and grab them. I'll grab one of this. Maybe I'll grab one of this in here. Okay. And then I'll probably grab, yeah, we got these two. These are the two types of parts that you typically have in here. And then maybe I'll go ahead and grab this one too.
Sure. Now, when you do your nest, when you have a drill and like a cutting operation at the same time, do you have to put those on separate layers, or can those all be done?
We can do automatically. It depends on how you want it to be done. So if you, in nesting, we can say maintain layers or maintain object colors, and I'm going to show you how we can take advantage of some of those in here. So I'm also going to go ahead and select these in here, just one of them, and I'm going to put it right in here, okay? So now I'll go ahead and select this one here, and I'll just place it right here, and then I'm going to go ahead and hide all of this in here, right here for now. Okay, I'll just put them on different layer. Okay, so I got these parts that you see here, right? I have 4 different parts right there. So I would like to nest them, these parts, into a sheet. So you go into RhinoCam and then select Nest. This displays your nesting interface. You have 2 types of nesting. You can do a true shape or you can do a rectangular. Now before you nest, you can specify or assign different colors for these. You can go into Properties and you can say Display Color. The holes, I can mark them in red. Now this particular shape, I can select these shapes in here. These are all going to be OD or outside cutouts in here. I'm going to select this, and I'm going to put them into a green color. And then for the ID, I'll just change the color to a blue. So you can see I've assigned different colors to it already. Now I'm going to go ahead and do a nesting in here, select the sheet. So I can have 1 or more sheets of the same size, or you can have different sheets. So you just have to draw the shape or the size, a rectangle, or whatever the sheet is. If you have a remnant, you just bring it in, draw the shape of it. And you can specify the quantity in here. And then you select the parts that you like to nest. You can say select curves. You just window out to select all of the objects. And you can see that there's a total of 4 different parts, and it automatically identified 2 holes on this particular part right there. So there's 2 holes. And the next step is you specify the orientation step angle in here. So you want to use any orientation of 90 degrees to fit it into the sheet, or you could specify any orientation of 45 or whatever angle that you want to put in. You can allow mirroring of parts inside other parts. You could do that. So if you have like a hole inside a part, you can fit in to maximize your sheet utilization. Then you specify the distance between each part right in here. So you can specify your part-to-part spacing. So depending on the size of the cutter you're going to be using. So if you're going to be using a 1/4-inch end mill, you want to give at least a little bit more room, maybe like 300 thousandths, different from the edge of the sheet to the part. So I'm going to put in 100 thousandths. And then I can specify if I want to like tag these parts, I can do that, and I can specify the quantity of these parts in here, which I forgot to do. I can put in how many of each of these parts I would like to have. I can specify a quantity for each of these parts right there. I could put in 10, and I could say I want to have all of them the same right here. I can specify a quantity for this. I can put in maybe 25 of these, and I can specify a quantity for each of these parts to be specified right in here. And now when I go down to choose nesting parameters, I can say execute nest. preview nest, you can see that it shows the result of your nesting right there. And since I chose allow parts inside parts, and you can see it's maximizing the utilization of your sheet. You see that, sir?
Yeah.
And now, once I have this in here, I could choose to commit the nest. I can even export them to a separate file. I can specify it. If I choose commit nest, it actually outputs it on a separate layer. So now if I go ahead and do a select objects, now all of this is in one layer. I'm going to export this out to a separate file in here. I'm going to call this part number 3. And now I'm going to go back to the milling module. And what I'm going to do here is, since we saved this to a knowledge base, I want to automate a lot of these processes in here. So I'm going to go in, load the knowledge base I created. And what I'm going to do here is edit the operation. I'm going to select the rules. I could say for a whole drilling operation, I would like to select all objects that are of a specific color in here. So I could choose, pick all objects of this specific color. So it'll automatically select them. Now for the profiling for the inside, I can use a filter and say pick all objects of the color blue. So I'm just using color as one of the selection techniques in here. I can say color filter again for the OD profile and pick all objects of color green. So now I've established rules for these, and I'm going to save them back to a knowledge base, and I'm going to call it the knowledge base with rules on it. Okay? Now, this particular file, the drawing that you have, does not contain any machining operations to it. So I'm going to go back and open this part, and you see that the part is out in here, and there aren't any machining operations to it. So the first thing I'm going to do is put the origin in here. So I'm going to select, align, set world, set to part, the lower left corner right there. Build my stock material in here. There's the stock defined right there. And then the next step, I'm going to load my knowledge base. I'm going to pick load knowledge base. I'm going to pick the one with the rules I put in here. And all I got to do is right-click and regenerate. So the objects are now automatically selected. I didn't have to go and even select the drill points because I said pick all objects of circles of color red. Pick all the IDs of profile blue and green. Since I organize them, I can just do a single button click to select. If I want to change the tool in here for any of these, I can just go back into my library, just drag and drop. So I could switch it to a quarter inch end mill, and all I got to do is go back and regenerate. So my tool paths are recomputed, and the part is now being ready to be post-processed. And you see that with just a few button clicks, once the rules were established, your programming of the tool path is fully automated.
Now what about making a program from parts from different files or different drawings?
You just bring them in here, and you can, the other way to do it is, let me go back and open up this part number 2 that we did. Right, so you can import drawings, you can do copy and paste, bring it in from different drawings into here, and then you just go ahead and you can load your knowledge base. I'm going to bring in the one that does not have a rules on it. You just double click and say you want to, if you need, there aren't any holes in here, so I can delete the drill operation out. I could do a profile. I could say in this particular case, I would like to profile all of these shapes in here. I want to do inside cuts for these shapes. So I can just go back and select them, generate it. Now I could go back and do the exterior profiles, and I can select these shapes right in here. Generate them. So you could bring in multiple drawings from different files. You just basically put them all in the same workspace and you start programming it. So we have solutions for milling. We have add-on for the nesting module in here. We have the art module if you want to go from art to part. We also have turning. So what I demoed you so far is the mill module, the standard configuration, and I also demoed you the nesting module where you can nest parts into a sheet.
It's a whole lot more advanced. I mean, it's a whole lot
more user-friendly.
Yeah, it's a whole lot. Bobcats are more like it reminds me of a cartoon, kind of the way it's set up, and I don't know if he's in here, Ron, when he said that before. He went in there, already had the program generated, and then went in, and you can actually, what we can't do now is a big thing for me is actually after you get the program in, put the drawing, it shows all your tool paths and everything. It'll actually save that tool path and everything as a file. So you can go back if something's wrong, you can go back and find out exactly what happened or where the tool path.
Change part of the tool path without changing all of
Yeah,
it.
because right now we can save programs, but you can't save anything else. I mean, so if you got a program and something came out wrong, you don't know where it went wrong at because you don't have no way of going back and checking and seeing what it done. One thing I really wish we was able to do.
With the mill module and the nesting module, is the price the same, or is it depending on how many modules you get?
Well, each of the modules are priced separately, so you can get them as a bundle, and I can, get that information out to you. So I can provide you with all the details depending on, if you're just looking for mill standard and nest, I can let you know what the cost for the, get the information to you for the mill and nest product. So we basically offer them as modules, so depending on what your needs are, you can choose those modules that, that'll help you accomplish programming, your programming needs. So you don't have to buy everything, like you don't have to buy, advanced 3-axis or 4 or 5-axis programming if you only have a need for 2 and 3-axis.
If we start with a 3-axis and then down the road get another machine of 5-axis, that's all within the same program, right? It's just a matter of selecting the...
Yeah, you just have to, so in this particular configuration, what I'm running, I have the top of the line, which is called Premium. I have full 5-axis programming capabilities. Now, if you just started with 2 or 3-axis programming and down the road you added a 5-axis machine, you just had to upgrade to the 5-axis module so you can get all the 5-axis capabilities. So if you are current, then you just have, it would basically be whatever is the, you would be basically paying what is kind of like a difference in the price between the configuration that you have and you want to upgrade to, so you don't have to repurchase the entire product.
Are you able to work with the milling layout from the 3D model?
Absolutely. So let me do this here. In this particular part, what I'm going to do is take this and turn it into a 3D model, right? So let's say on this part, I'm going to go ahead and do some extrusions in here. So I'm going to select these parts. For programming 2.5-axis or 2-axis operations, you can either work off 2D drawings or you can work off solid models as well. So I can select these objects in here and do an extrusion, solid, extrude, planar curve straight. I can give it a height in here to the extrusion. I can say minus 0.75. So I can work with solid models too. So I could go ahead and program 2-axis operations. I could do profiling, pocketing, and I can select these options. Or I can go directly and do a 3-axis operation. I can do a method called finishing, which is offered right from the standard configuration. I can pick a tool, and I can specify to do what is called finishing in levels. This is like your profiling. This does a Z-level finishing toolpath, and you can specify your step down. So this automatically follows around the contour of the part and creates finishing toolpaths for you. So we have a wide range of toolpath methods in 2 and 3-axis. There's your Z-level finishing just off of a 3D model. I didn't even have to pick any objects in here, so it knows that it needs to follow the outside, and we can control the step down, how fine you want to cut out a step. So this is the machine.
Like the 3D model that we looked at when we first opened the file was like this assembly. Mm-hmm. You can't work with that directly, right?
Yeah, here's what we could do with the assembly, and I'm going to show that to you. Let me go back into this file in here. I think it's on this layer right there. Okay, so there are basically you have some poly surfaces and surfaces in here and extrusions right there.
Right.
So what we could do is we have a method or a very nice feature called Explode Cabinet Design. So if you go into the utilities in here, you can select Explode Cabinet Design, and you can say Explode all objects that are visible in here, and you can specify to space them apart at a distance. You can specify a spacing, and you can either create both 3D geometries and 2D curves. So I could say only create, and then place all the curves on one plane. And then when you pick OK, it actually decomposes the part, and then it creates 2D for you.
Okay.
That's a very nice tool. That's called Explode Cabinet Design. So which means it can explode any, flat panels, or it's just not just for cabinets. You can explode it. And then once you have this exploded in here, you can go into the nesting module to have this nested into a sheet in here. So I can draw a sheet in here. I can go ahead and say the sheet I'm going to be working on is going to be 96 by 48. So I'm going to put in, so there's my sheet right there. I can go into the nesting program and then nest all of these parts into the sheet. So I'm going to pick the sheet right here. And then for the parts, I'm going to select all of these right there, the ones that we created from the Explode Cabinet Design. And I go in and specify the spacing in here. So I could say 0.4, 0.1. And then you can specify estimate number of sheets. It'll tell you how many sheets you would need to nest this. It says you need a minimum of 2 sheets. And I can update the sheet count in here. And now I can execute the nest. You can either have the sheets stacked, or you can have them arrayed side by side. So it's creating the nest, previewing the nest. You have 2 sheets. There's your sheet number 1, sheet number 2. And then you can do a commit nest. So these sheets are output in these 2 layers right there. And now we can program our toolpaths to it.